Hi guys, today we are going to start Unit 7. If you are watching this video, it means that we are not together, which is totally fine because we are going to get this information and we are going to understand it and then move on to doing things with it. So the good thing about this unit is you learned this in middle school. We are going to build off of what you learned about energy and heat and how that energy and heat can be transferred to other objects. So when we talk about energy, we are talking about the law of conservation of energy, really. If we look at slide 3, we see that the law of conservation of energy, and we remember from talking about this with the law of conservation of mass as well, is that energy cannot be created or destroyed. Energy can be in several different forms, and we can transfer energy from one form to another without destroying or creating new energy. So what we want to look at is when we look at this digital notebook, this is your new digital notebook, and you find it in Google Classroom. It won't be posted multiple times. So every day when you use this notebook until it is finished, you'll be going to the same place to find it. In your Google Classroom, it will say new digital notebook. So just be sure you find that in the same spot. You can also go to Google Drive and type in digital notebook or find that in your files there. Okay, so what we're going to do is each time I start a new section of this digital notebook, I'll start a new video. So you need to watch this video to completion and then go back to Google Classroom and see what the post says to do during and after the video. So just be sure you're watching this and follow along as we go. So we know that the goal here is to try to explain how energy is transformed within a system. So for example, in your body, which is a system, we convert energy in several different forms. So for example, let's just think of the main form as eating. You eat food to gain energy. When you do that, there is chemical energy stored in bonds inside the food. When you eat them, your body breaks those bonds, breaks that energy down, and it is stored in your body, and some of it is used to create heat if you exercise. Some of it is used as other chemical forms in our brain when we send chemical impulses to our brain. Some of it is used to talk, which is sound energy when you talk. So we're going to talk a little bit more about that. So I want you to click on slide 3. Let's look at the conservation of energy in this power plant right here. So this is a hydroelectric power plant. You see water right here with lots of stored potential energy in that water. As it flows down this little tube right here, pathway, it starts to gain kinetic energy. When it does that, it takes a stationary object like a turbine, and as it flows through, it spins it. So you've got potential energy being converted into kinetic energy that then turns this turbine to create mechanical energy. Now, when it spins, that mechanical energy is then converted into electrical energy, or the flow of electrons through wires, and it is stored in a generator. When it is sent to your house through long power lines, that electrical energy, the flow of electrons, goes into your outlets and your wires and the wiring of your house. And when you plug an item in, you draw on that electrical energy that started as potential energy. So what is energy? It is the ability to do work. We know that work is a force acting over a distance. So we need energy to apply a force over a distance. So energy is needed to change things from one form to another, even when we're talking about solid, liquid, and gases. You know that a solid state has very little energy and a gas has a lot of energy, usually thermal energy and heat. So as we change from that solid, very little motion of particles state to a gas with a lot of motion, it takes energy to change those states. Now, when we click on the next slide, I want you to pause this video and watch the video right here. So you need to stop, pause this video, and click on the video that says energy transformation. We need to understand energy transformations in a mathematical form in order to look at it in a more basic form. So pause this and watch this video. All right, now that you've finished, hopefully you've watched this video, you saw this diagram. in the video. It's called a Sankey diagram. We'll talk about that in just a second. My answers are in yellow here. So on your digital notebook, you have a blank. I want you to put the answers that I put into this slide into yours. You can change it a little bit. The question says, what is the difference between stored energy, potential energy, and energy of motion, which is kinetic energy? Well, potential energy, such as gasoline, if you have gasoline, we know that is not moving energy, it's just chemical stored energy. Once we put that into a car, it can change into kinetic energy as the car starts to move. And the energy of that relates to the speed of the particles. That gasoline, once combustion happens in the engine, which we'll talk more about later, you start to see a lot of motion in those particles. So is energy input equal to energy output? When we think of the law of conservation of energy, we understand that we can't create or destroy energy. So energy in must equal energy out. But here's what's important. We need to think about useful energy. So if you look at this Sankey diagram right here, we see that we put gasoline into the car. 100% of that gasoline comes out, but all of it is not useful. So 40% of the gasoline you put into your car is used to move the car forward. The other 60 is wasted as heat from the car. If you stand next to a car, you know it produces heat, sound energy. So just remember that when we look at this, all energy that is put in is coming out. It's not destroyed, but it is not all useful. So you have to be careful and see if we're asking about useful energy input and output. So explaining the Sankey diagram, if you can see it, used in physics, it shows the conversion of energy. And you can see the length of the arrows are proportional to how much this 60% arrow is much larger than the 40% arrow. Okay, so when we look at a Sankey diagram, just be sure you understand it shows that the energy input is equal to the energy output, but not all of that energy output is useful. All right? So in slide number 6, we know, like we said, the law of conservation of energy says that energy is not created or destroyed, but it is transferred. So light energy that comes from the sun, we can also call that radiant energy, or electromagnetic energy, because we know that visible light is on the electromagnetic spectrum. When it is absorbed by plants, it is converted into chemicals in that plant to give us energy when we eat the plant. So here we see light from the sun being used to create chemical reactions in the plant. Also, let's say you plug in a hot plate, or you want to cook something. That is your stove or oven is usually plugged into the wall. When you do that, electrical energy, the electrons flowing through those wires, are used to create heat, which is a conversion of energy. We convert our electrical energy into heat. Chemical energy in ice cream, when you eat it, probably not the best choice before a bike ride, is used to create mechanical energy in you. You can move when you have chemical energy from food. And then in the same way, chemical energy from gasoline acts as the food for the car as it moves forward. But remember, some of that gasoline energy is lost as heat. Some of it is useful for making the car move forward. All right, so we've got different types of energy. We will primarily, since the whole unit is called energy and heat, we will primarily focus on thermal energy a lot. You'll hear that a lot. We have different types. Mechanical energy of motion. Thermal is heat energy. Electromagnetic energy, that is energy that we usually see as visible light or any type of energy on the electromagnetic spectrum, which could be anything from radio waves to gamma rays. Okay. Electrical energy is energy from the flow of electrons. And usually we see that in things that we plug into an outlet. So you can also see that in lightning. You can see electricity build up and then release. Nuclear energy, used in power plants when we take the nucleus of an atom and convert that into useful energy. That is nuclear energy. That also happens in the sun with fusion. Don't forget, the sun undergoes nuclear energy every day to create that heat and light that we need. Chemical energy. Sometimes we see this in the lab. We have different chemicals. We eat foods that are created of chemicals. Chemical energy is energy that's stored in the bonds of atoms. And we'll see conversions in all of these types of energy. So, right here, you have mechanical energy, energy of motion. Whether you are on a roller coaster, you're riding a bicycle, you're hammering a nail, When objects are pushing or pulling on something, it is undergoing some sort of mechanical energy. There is mechanical energy there. Thermal energy is the total, you got to think about this carefully. We think of thermal as heat, and it is. But thermal energy is the total kinetic energy in an object. So the amount of kinetic energy in you is your thermal energy. So what that means is, think about it. When you move more, you create more heat in your body, which is more thermal energy. So thermal energy is the kinetic energy in an object. The more heat we have, the more kinetic energy. Electromagnetic energy. This is any energy that you can find on the electromagnetic spectrum. And when energy is created by changing electric and magnetic fields, we see this electromagnetic energy. It can be transmitted through matter or empty space. So think of sunlight. It goes through space. It also travels through the air, which has matter in it. And sunlight is a good example. Visible light from the sun, UV radiation, those are both on the electromagnetic spectrum. But I just want you to remember, we can call electromagnetic energy light energy and radiant energy as well. Electrical energy. When energy is flowing through wires, we call that electrical energy. So electrical source is connected to a complete circuit. We have movement of electrons through conducting wires. That is your electrical energy. Nuclear energy, energy that is stored in the atoms and bonds of the nucleus of an atom, and then the nucleus is either split or combined. That is nuclear energy. So fission and fusion. Fission in power plants, fusion in the sun, those are our types of nuclear energy. Chemical energy is required to break bonds and make bonds. So when you eat food and your body breaks down those bonds, that is a release of chemical energy. That chemical energy is being converted into something else in your body. Food and fuel are both really good examples of chemical energy. So when you see food and fuel, fuel is in gasoline, that could be an example of chemical energy. So what I want you to do is, on slide 14, I want you to match the picture with the correct word. So pause this video, click on slide 14 and match the correct picture with the word. And then come back to this video. Okay, now that you're back, hopefully you've already put all the pictures in slide 14. Here's what you should have. Chemical energy inside of a firework, once it is, once what they set off that firework, once they add heat to that, it causes those chemical bonds to break and release color, sound, usually an odor as well. Electrical energy, when you plug in a computer, the electricity creates different things in that computer. It creates sound, light. Heat energy. This fire is definitely heat or thermal energy. We can use both of those words. And then mechanical energy, the Ferris wheel moves. That is definitely moving parts. So mechanical energy. A man playing a trumpet, that is sound energy. He's probably using chemical energy from his food to create the mechanical energy in his fingers and in his voice to create that sound. Nuclear energy, we have a nuclear power plant. Fission happens there. That is breaking a nuclear bond that releases nuclear energy. Light, we have a light bulb here. And the main result of a light bulb being lit is to provide light or radiant. You could also call it electromagnetic energy. All right, so you are going to pause this video now, go back to Google Classroom, and look for the rest of the assignment.